What we want to add to that is what to do with multiplying and dividing derivatives, because regular multiplication doesn't work and regular division doesn't work. Can you think of anything in your math history where multiplication wasn't treated like straight multiplication? Logs. What did multiplication, what did we have to do with logs? It became addition. And what did quotient or division become? And you know what? So much the same with calculus. Okay, when you have is Isaiah? Was that your phone? Okay. Same with multiplication. Multiplication becomes addition in calculus with derivatives, and quotient becomes subtraction. So I just want to show you how that works. All right, here's the rule number 5. So our rules so far have been, rule number 1 was how do you take the derivative of a constant? That was 0. Rule 2 was how do you take the derivative of a line? And that was just its slope. Rule 3 was the power rule. Rule 4 was that you're allowed to add or subtract. Rule 5 is that you need something special for multiplication. If you can squeeze in a little multiplication like in between there, that would be helpful, or whatever you want to use. Multiplication turns into addition. And it's a special kind of addition, and this is how it goes. You start with V. The last shall be first, okay? The last part of the equation, the V, comes first. Next to it, or multiplied by it, will come du dx, or the derivative of the piece of the function that was u. So it's one regular function and one derivative function. After the addition sign, you flip-flop those, and you do the regular u function and the dv dx function. So in other words, there are 4 parts to it. It's easier when I actually show you how to do it, but it takes any product becomes the addition of 2 separate pieces. Let me show you how it works. Let's take this problem. Okay? This is a product. The derivative of this, df dx, is going to become an addition. Okay? Sometimes it's nice to just sort of fill out the parts so you can plug all the right things into the right spots. We start with the last shall be first. So the last part was 3x plus 4, and we start with that. That goes here. The next part is the derivative of the other factor. So the derivative of that is 2. And then after, we do the reverse. We do 2x minus 1, and then we finish with the derivative of the last factor, which was 3. That is called the product rule. That's the product rule in action. In this class, you don't ever have to prove the product rule. Okay, if you stick with me for Calc BC, or you end up taking Calc 2 in college, that'll be that level that you do that. And then you just have to clean it up. So what will I do with this number 2 that's sitting here? Okay, distribute it. So I'm going to distribute it, and I'll end up with 6x plus 8. And then I do the same thing with the 3. I distribute that. I end up with 6x minus 3, so my whole derivative becomes 12x plus 5. Okay, any questions on that so far? Okay, so just keep practicing that a couple times. So what if your factors look like that? What if it's a multiplication that looks like that? It's got one that's a cubic and one that's a square. All right, so your f prime of x is going to follow the product rule. So products become addition. Addition has 2 parts in the front and 2 parts in the back. So we'll start with the last shall be first. So x cubed plus 3. Right. And then we'll do the derivative of the first part, which according to the power rule is 3x squared. And then we do the reverse. We have x cubed minus 4. And then followed by the last derivative, which is just going to be 2x. And then it's just a matter of distributing, cleaning up, and adding any like terms you might have. So this will give me 3x to the 4th plus 9x squared. And then 2x to the 4th minus 8x. So any like terms I can combine together. So I'll have 5x to the 4th plus 9x squared minus 8x. So this is the derivative. And what does the derivative have the power to tell me? Not if it's continuous, but what about the function can it tell me? It tells me about its slope. What's another word for slope? Let's keep practicing so we can keep fresh. Okay, well, derivative is the same as slope. Slope is another word. Tangent, another word. Okay, how about instantaneous rate of change? Okay, yep. So all of those, it can tell us all of those things. The derivative can tell us the slope. It can tell us the tangent. It can tell us the instantaneous rate of change. There's going to be more things that we add. That the derivative can tell us all those things. All right, so you feel good about the product rule? It's not a very hard one. Okay, then we have the quotient rule. The quotient rule is subtraction. Similar. So now we have subtraction. Okay. So the main big difference is that this is subtraction. The other, and you may, if you didn't leave yourself room, there is a denominator. Okay. So if you didn't leave yourself room, use Notability and slide it up. But you start the same. V comes first. So the last shall be first. The bottom shall be first. And then du dx, so the derivative of u with the variable x. And then u minus u, and then dv dx. So it looks a lot like the product rule. It's the same order as the product rule, just with a subtraction. Okay? And then it does have a denominator. And the denominator is the original denominator squared. Not the derivative denominator, just the original denominator squared. So the order is important because if you have the order wrong in the numerator, then your answer will be the negative of what it should be. So make sure the last shall be first or the bottom shall be first, however you're going to remember that to make sure that you're doing it in the right order. Okay, so we'll just do a couple sample problems. Everybody, these tend to be, I would say, if math homework could be popular, these tend to be the more popular homework assignments because there's no word problems in them. They're all just like practice the rule over and over again. So we'll do f prime here. So my f prime is going to be a subtraction. It's going to have the 4 parts in the top, and then I'll deal with the denominator in just a minute. So I'm going to start with the bottom, so x squared plus 3. And then multiplied by the derivative, so 3x squared. Bless you. And then we'll have x cubed minus 4, and then the derivative of 2x. My denominator is my original denominator, but squared. Now, in terms of cleanup, you want to focus all your energy on the numerator. You don't have to worry about the denominator. You don't have to expand or FOIL it. Just leave the denominator as what it is. Put your energy in the numerator. The places where people will make slight errors is that they will forget that the negative distributes to everything that comes behind. So a lot of times the 2x would get distributed, but you have to remember that the negative would get distributed also. So that would be one place where people, especially in a multiple choice, might make an error. So we're going to look at 3x to the 4th plus 9x squared minus 2x to the 4th, but then plus 8x. So it's that plus 8x that often, people make a minus 8x and they just make a quick error and they're just missing that. The bottom you don't have to do anything with. Okay, you can just leave it as x squared plus 3 to the quantity squared. So the only other thing you would need to do is if the numerator does have some like terms to put together, that we could combine them. So we have 2x to the 4th terms. So we just have a single x to the 4th plus 9x squared plus 8x. And then my denominator would be x squared plus 3 squared. So that will tell me the slope. It can tell me the tangent line. It can tell me the instantaneous rate of change. I can set this equal to 0 to find any parallel places. I can set this equal to 0 to find any horizontal places. I can do more with it. That's the beginning part of it. So let's do a little bit more with that. If that is your equation, use the derivative to find where the horizontal and vertical tangents are. So we'll set up the derivative of q first, so q prime. We'll start out with our subtraction and our denominator. So all the pieces, we start with x plus 3 because the bottom always goes first, and then 2x minus 4. And then we'll finish up with x squared minus 4x, and then 1. The denominator will stay x plus 3. So then we'll clean that up a little bit. Again, the numerator is where you're going to put most of your energy. So I have to FOIL the first two factors together. So that'll be 2x to the second minus 4x plus 6x minus 12. So I have to FOIL that all together. I also have to distribute the negative to make sure that it impacts the terms that come behind it. So that would be minus x squared plus 4x. And then the whole denominator remains unchanged. Yeah?
Where did the 2x plus 4 come from?
2x minus 4?
Yeah, 2x minus 4.
That was the derivative of these two pieces.
Oh.
Okay, the derivative of x squared is 2x. The derivative minus 4x is. All right, good question. All right, so then let's just see what this looks like cleaned up. I have x squared, let's see, 2x plus 6x minus 12 all over x plus 3 quantity squared. So I think I did that. Okay. So that's the derivative. Now we can use our derivative to find both horizontal tangents and vertical tangents. When you want to find a horizontal means you're looking for a slope that is 0. So you're going to take x squared plus 6x minus 12 over x plus 3 squared, and you're going to set that equal to 0. When you do vertical, a vertical slope, a vertical tangent, is the same derivative, but it's set equal to 1 over 0 because it's set equal to infinity. So maybe we'll show that first. We're going to set 1 equal to 0 and 1 equal to infinity. So algebraically, I want you to put a 1 under the 0, and then I want you to make the infinity as 1 over 0. Because I feel like if we set it up that way, your brain, hopefully, will say, oh, when I look at something like that and I see the 0 over 1 or the 1 over the 0, what does your brain, I hope your brain remembers that you've seen this before. And what have you done with this before? Cross multiply, exactly. You're just going to cross multiply. So that's why I love putting the ones in there, the 1 over 0 and the 0 over 1, but make sure you know which is which. One of them is for horizontal and one of them is for vertical. When you cross multiply, for the horizontal, you'll get x squared plus 6x minus 12 equals 0. For the vertical, when you cross multiply, you'll get x plus 3 squared equals 0. And both of those can be solved either with factoring or the quadratic formula or with your graphing calculator if you have that. So you would go to then, I would say this one's going to be x equals negative 3. That will be vertical. For the horizontal, we'll have negative 6 plus or minus the square root of 36 minus 4 times negative 12 all over 2. And then you'd have your solutions there. All right, last thing. Sometimes you get questions that look like this. You're given 4 values at the beginning. Well, you're given at x is 5, you have 4 different values. You're given 7 and 2 and negative 3 and 6. In other words, you're given 2 points and 2 slopes. Okay, you're given the point, the u point of 5, 7. You're given the v point of 5, 2. You're given the u slope of negative 3. You're given the v slope. You're being recorded. Of 6. I would say ignore that. Like, if you're asked to then find the derivative, do the derivative rule first without any numbers in it. Okay, do the derivative rule first. So this one, your derivative rule is going to start with the bottom shall be first, so v. And then it will be du dx minus u times dv dx all over v squared. Then go, okay, for regular v, I'm supposed to put the point in. For du dv, I'm supposed to put the slope in. And then for regular u, I'm supposed to put the point in. And for v prime, I'm supposed to put the slope in. So then go back and grab your numbers. So the point would be 2, the slope would be negative 3. The next point would be 7, and the slope would be 6, all over 5 squared. So make sure you're putting the points in the right spot and the slope in the right spot. Okay, just one comment about part B. What would you do? I showed you how to do a U and a V, but now what do you do with the 10 sitting out front? Okay, 10 is a constant. It can come in the front of your problem, like pull it out, and then do the regular product rule first, and then times it by 10 at the end when you are finished. Okay? Yeah, Nico. V, oh, whoops, it's supposed to be a 2. Thanks. Okay. All right.